folks, welcome back to my YouTube channel Code to Create. In today's video, we're going to see how to create a model that predicts the next day's maximum and minimum temperature. So let's get started. I'm going to create a new Python 3 file in Jupyter Notebook. And then we have to import the necessary libraries. So let's do that. I'm going to import pandas for reading the file and everything about the file. And then I'm going to import numpy for all the EDA stuffs. And then I'm going to import matplotlib. I'm going to import matplotlib for the visualization. So I'm going to say from matplotlib import pyplot as tld. And then I'm going to import cbond. So I'm going to say import cbond as sns. And then I'm going to import standard scaler. So I'm going to say from sklearn.preprocessing import standard scaler. And then we have to import grid search CV and train test split. So I'm going to do that. I'm going to say from sklearn.model selection import train test split and grid search CV. Grid search CV. And then I'm going to import mean absolute error from metrics. So I'm going to say from sklearn.metrics import mean squared error. And also let's import the R2 score. Let's run this up. Yes, no errors. And after this, we're going to read our data set. So I'm going to say df is equal to pd.read_csv. It's in the form of CSV. I'm going to go up to my file. And here I'm going to go up to my desktop. And let's go up to my temperature forecast. And I have my data set over here. Let me copy this. Put it up here. And then I'm going to slash temperature.csv. Sorry. Yes. Let me show you guys our data set first. So we have our station, we have the date, and then we have present temperature maximum, present temperature minimum, and then so on columns. And after this, let's take a bit of information about this data set. So I'm going to say df.info. Yes, and here we have float and object data type. And we can see we have the count of how many no null values are there. In station we have 7,750 non-null values. In date we have 7,750 non-null values. In present temperature maximum we have 7,682 non-null values, and so on. And then let's see if our data set have any null values. So I'm going to say df.isNull.sum. Yes, you guys can see we have few null values up here. In station we have 2, in date we have 2, in present temperature maximum we have 70, in present temperature minimum we have 70, and so on. So here what we're going to do is in station we have only 2 null values. So let's clear this null values up. I'm going to say df of station dot iloc. That's the row number in this particular column. And then I'm going to set it to 1.0. Let's do the same for the next null value too. We have 2 null values as I said. So I'm going to say let's do this for the second null value. So I'm going to say df of station.iloc. And here it's going to be 7,751 is equal to 2.0. And now let's replace this null values in our date column with next day of 38/2017. You guys can see over here we have 2 null values in date 2. So let's rename this up, or let's clear the null values up there. Oh yes. I'm going to say df of date dot iloc. And this is going to be of 7,750 row number in that column, in date column, is equal to, we are going to set the date to 38/2017. Yes. Let's do the same for the other null value. So I'm going to copy this up, paste it down here, and let's change the row number. Let's set it to 7751. Now let's run this up. Yes. Next, let's drop this latitude and longitude column, as it just indicates this graphical condition up here, and there's very less use in our prediction. So I'm going to do that. I'm going to say df.drop columns is equal to, as it's multiple columns, I'm going to say columns is equal to, else we can directly say df of latitude and longitude. I'm going to say lat, comma, long. Oh, sorry. Yes. And then let's say, set the in place to true, as we don't want it in our data set. Let's run this up. Yes. Now let's replace all the null values with median. So I'm going to say for column in df.column, so it's going to be of all columns. I'm going to say if column not in station and date, as we've already filled this station and date, comma date, then df of column, then df of column dot replace. We're going to replace it with median. So first we have to replace null values. So I'm going to say np.nan, and we're going to replace this df.column with median. Yes. Yes. Let's run this up. Now let's check this null values again. I'm going to say df.isNull dot sum. Okay. There should be something wrong up here. We want to clear all the null values. Oh yes guys, we've done a small mistake. What we have to do over here is we're going to say df of column up here is equal to df of column dot replace. Let's try this again and check if all null values are cleared. Yes, we have cleared all our null values with medium. Now let's convert this date type of date column to date type. I'm going to say df of date dot is equal to df of date is equal to pd dot to date time df of date. Let's run this up. And now let's check the correlation between the variables. So I'm going to say df underscore core, that's correlation, is equal to df dot core, that's correlation. I'm going to plot this up. So I'm going to say plt dot figure, the figure size is going to be, and let's set the figure size to 25 and 15. And then I'm going to come down and use the heat map from Seaborn. So I'm going to say sns dot heat map df of correlation, df correlation, and then I'm going to set the v minimum to -1 and the v maximum to +1, and then let's set the annotation to true and square boxes to true and center as 0, center is equal to 0, and let's set the SMT to 0.2, set the line width to 0.1. I'll say line width is equal to 0.1. Then I'm going to say plt dot tight layout. Oh, we've done a small mistake. Okay. Yes, let's set this to RR. So this is going to be our correlation plot. Next, let's check our skewness of our data set. I'm going to say df.skew. Yes, we can say that most of them are normal. And now it's time for removing our outliers by using zcore method. So let's do that. I'm going to import stats from Skype. I'm going to say from Skype import stats, and then again from Skype.stats I'm going to import zscore. So let's say from Skype.stats import z-score. Next, for which one we should input our z-score method, that one we have to do. I'm going to say z_score is equal to z-score of df, our data frame, that is our data frame. I'm going to take the present tmax, present tmin, that's present temperature maximum, present temperature minimum, tmin, and then LDAPS RH max, and then LDAPS Tmax labs, and then LDAPS Tmax minimum we have to, T minimum we have to do, and then we have to do LDAPS T minimum labs. So let's copy the same thing and change it up. Let's do this. Yes, minimum. Minimum labs, and then LDAPS WS, and let's fill the rest columns. Yes, and then I'm gonna say z-score is equal to np.abs z-score. We've put the z-score. Now I'm gonna filter this entry, so I'm gonna say filtering entry is equal to ABS z-score should be smaller than 3. Should be smaller than 3 dot all, and I'm gonna set the access to 1, and then I'm gonna set this df to df filtering. The filtering entry, and then let's reset df. So I'm gonna say df dot reset index. Let's reset its index in place is equal to true. Oh, it shows the error. Filtering entity. Oh, yeah, yes. Now let's run this up. Yes. And now we have to convert this date column into numeric values. Let's use ordinal encoder. So I'm going to say from sklearn.preprocessing import ordinal encoder. Yes, I'm going to say enc is equal to ordinal encoder. Yes, and then I'm going to say df of date is equal to enc.fit, that's our ordinal encoder.fit transform. Transform df.date. We're going to transform this date, so I'm going to say df of date dot values. We're going to transform the values, and we're going to reshape it to -1 and 1. -1 and 1. Let's run this up. Yes, and now we have to divide our data set into x and y. So let's do that. I'm going to say x is equal to df dot drop next tmax, that is going to be our, we're going to drop next tmax and next tmin, that's our target variable. So I'm going to say next tmin, and that's next temperature next day temperature maximum and next day temperature minimum. I'm going to set the access to 1, and then let's do the same for y. I'm going to say y is equal to df of, remember guys, put 2 square brackets or else show an error, next tmax and next tmin. Yes, let's run this up. Yes. Next, let's see our skewness in other features that there's more skewness or less skewness. So let's do that. I'm going to say from index in x.skew dot index. If x.skew dot log index. So we're going to say if our skewness of x is going to be greater than 0.5, then we're going to set our x index is equal to np.cbrt. It's a function. cbrt is a function, an inbuilt function, x of index, to treat our skewness. And then I'm going to say if x dot skew dot log of index is 0.5, then x of index is equal to np dot square x of index. Oh no. Oh, sorry, I have to put x over here. Yes, now let's check our skewness again, our x skewness. We have a bit more. Yes, so we can see we have treated most of our skewness. Now let's bring all these numerical features to a common scale using standard scalar. Let's do that. I'm going to say scalar is equal to standard scalar. I'm just going to create a class up here. Scalar. And then I'm going to say x is equal to scalar dot fit transform. So guys, fit transform is going to be like if any variable that's in categorical way, it's going to transform into numerical way. That's it. Fit transform x. And I'm going to say x is equal to pd dot data frame. We're going to convert this into a data frame. And it's going to be x and columns are going to be x dot columns. Yes. And now we have to find our random state, our best random state. So let's do that. I'm going to say from sklearn.linear model, I'm going to import linear regression. Model, import linear regression. Max R score is going to be, I'm going to set our max R score to 0. I'm going to set our R state also to 0. And then I'm going to say in range for I in range of 1200. X train comma x test, x test comma y train comma y test is equal to train test split x and y, and I'm gonna set the test size, test size to 0.25 and the random state to R state, and then I'm going to create a class for linear regression. So I'm going to say reg is equal to linear regression. Regression is equal to linear regression in short form. I'm going to say reg dot fit x train comma y train, and then I'm going to say y predict is equal to reg dot predict x test. We're going to predict our x test, and then comes our R2 score. I'm going to say R2 score is equal to R2 score of y test and y predict. And then we're going to create a if condition. I'm going to say if R2 score is going to be more than our max R score, then max R score is going to be R2 score. Is going to be R2 score. And we're going to set the R state to I. Yes. And then let's print our output from what we got from this for condition. So I'm going to say print max R2 score is, let's print our score, max R score, and then let's say on random state, let's print our random state. That's our R state. Yes, let's, oh god, another error. Okay, invalid parameters passed. We've said, oh sorry guys, sorry, I just put test. Let's put it as test size, and now it should show no errors. Yes, our R2 score is 0.79 and our random state, our best random state is 2. Now let's split our data set with the best random state, that is 2. So let's do that. I'm going to say x train comma x test comma y train comma y test is equal to train test split x and y, and let's set this test size to same 0.25, and our random state to 2. Yes guys, so after splitting our data set up, we have to train our model using a particular algorithm. Let's do that using extra tree regressor. I'm going to say from sklearn.ensemble import extra trees regressor, and then I'm going to say ext is equal to extra tree regressor. I'm just going to create a class up here, and then I'm going to fit this up. I'm going to fit our x train and y train. So I'm going to say ext.fit x train comma y train, and then we are going to create our y prediction variable. I'm going to say ypred is equal to ext.predict x train, and then I'm going to say pred ext is equal to ext.predict x test, and our R score should be up here. So I'm going to say R2 score is equal to R2 score of y test and y and our predict ext multiplied by 100. Yes, let's run. Oh okay, and why is that? From sklearn.ensemble import. Oh guys, we've done a small mistake, spelling mistake. Let's correct this up. Yes, and now to make it with the best parameters, let's use grid search CV. So I'm going to say gcv is equal to grid search CV, and we're going to use our extra tree regressor model, trees regressor comma grid params, and let's set our CV to 5. Say gcv.fit x train comma y train. Oh, we forgot to define our grids parameters, so let's do that. I'm going to say grid params is equal to, we should use a curly braces. If you guys remember, we should use a curly braces. We have to set our max depth first. I'm going to say max depth. I'm going to set it to 8, 9, 10, 12, 15 and 20. Let's set our n estimators to 500, 700, 1000 and 1200. And then let's set our minimum sample split to 2 and 3. Yes, let's run this up and run this up, and now there should be no errors. Let's just directly create our model 1 up here. Let's create our model. I'm going to say model 1 is equal to extra trees regressor. Sorry, trees. Extra trees regressor. Max depth to 20 and n estimators to, let's set our estimators to 500, and minimum sample split to 2. Samples split to 2. I'm going to say model 1.fit extend and weight train. Let's create our prediction variable up here. I'm going to say y predict is equal to model 1 dot predict x train, and let's set our actual prediction model to model 1 dot predict x test. So yes guys, I've done this up and I've ran complete whole thing. Let's check our prediction, and this is our prediction and this is our y prediction. So yeah guys, now we know how to create a model that predicts the next day maximum and minimum temperature. Thank you friends. Please do like, share, subscribe and comment below. Bye bye.